Hello friends, welcome to our YouTube channel, Our Padhing. So in this lecture we will talk about the stress strain curve. Basically, the stress strain curve is drawn for a mild steel. While mild steel we choose, in the civil engineering point of view, there is lots of use for steel. In the RCC and other construction for welded purpose, the steel are used. So that's why we choose in the testing mild steel. Why we choose the mild steel? There is three reasons for that. That is, first reason is the steel is equally strong in tension and compression both. The steel will be used because of that reason. It is strong in tension and compression both, and it is a ductile material. So the failure will be ductile in nature. And the second reason is the coefficient of thermal expansion for steel and the coefficient of thermal expansion of concrete will be equal. And the third reason is the steel can be easily welded. There are three reasons for choosing the mild steel. The testing equipment is used, that is UTM, Universal Testing Machine, and the universal has the name universal, that is universal use. It can be used for a bond test, tension test, compression test, bearing test, and shear test, and so on. This machine has two units. One is loading unit and second is measuring unit. The loading unit is we can apply the force, and in the measuring unit you can measure the deflection. As you can see in figure, there is universal testing machine. There is two units. One is loading unit and second is measuring unit. So this, as per the ASTM, this bar is used for a tension test. This L naught represent the gauge length, D naught represent the gauge dia, and this portion of the bar which is grooved on this portion is embedded into the machine, and this is a standard form of this bar, that is L naught divided by D naught is equal to 4. So from the force you can calculate the stress by using the formula force upon area, and from the deflection you can measure the strain value by calculating the formula by the, that is change in length, that is deflection, divided by the original length of the bar. This is the stress strain curve which is found for the mild steel. In the x-axis you can say strain is there, and in y-axis that is stress. So here question will arise, why we choose the stress in a y-axis. So for example, y is the function of x, suppose. So y equal to, we can say m into x. Suppose linear variation are in between y and x, so y equal to mx. If linear variation is not there, so x square, x cube, whatever we will have. So y equal to mx. So the value of x is changing, y is changing. The y is dependent on x. So here similarly strain is we can calculate. In first lecture we will talk about why the stress is not calculated directly. Strain can be calculated, and from strain applying Hooke's law and you can compute the stresses. So the fundamental property is always on x-axis, and calculated value, calculated property is on the y-axis. So x, in the x-axis strain will be there and y-axis stress will be there. As we apply the load, the deflection will be occur and the stress will be occur, strain will be occur. Up to the value, up to the point A, there is elastic variation. Elastic, that means a linear variation in the up to A, and that is called A is a proportional limit, and B is called elastic limit. What is elastic limit? Elastic limit is that limit in which you can remove the load and the material, the bar, gets tendency to regain its shape up to the elastic limit. That limit is known as what? Elastic limit. C dash point is shown is upper yield point, and the C point is known as lower yield point. This is upper yield point, this is lower yield point. In actual, we take the yield point is as lower yield point. Why we not choose this value C dash? C dash is the not a fixed value. It will be fluctuating value. So it is a long theory which is discussed in different lecture. That is slipping of molecules, slipping of carbon molecules or whatever will be material in that. So that is slipping of molecules. So that's why this point is fluctuating. So we choose the yield value is this C point, and up to the D, that is zigzag path is known. And this zigzag curve is the simple that shows the plastic deformation. Without changing in stress, the strain will be keep on increasing. That shows the plastic region, plastic behavior of that. And then strain hardening, and E is the point which is shown ultimate stress value. Then F, this is strain softening. After that F will be found, that is fracture point. Okay. So this is a stress strain curve. In A, that is proportional limit, B is the elastic limit, C dash is upper yield point, C is lower yield point, CD is the yield plateau region, or you can say the plastic region. Strain hardening, E is the ultimate stress value, and F is the fracture point. This is the proportional limit, B is the elastic limit, upper yield point, lower yield point. This deep value is the for zigzag path. E is the ultimate stress point, F is the fracture point, CD is the plastic region, D is the strain hardening region, then EF is the strain softening region. Then fracture point will be obtained, that is F, and then fracture is two type. That depend upon material. It will be brittle material, or it will be ductile material. For brittle material, that is rupture failure will be seen. But in ductile material, that is cup cone failure will be there. So in the cup cone failure, that angle will be made, that is 40 degree, and in this 90 degree will be obtained. That is cup and cone. That is cone is fitted into the cup and it will be on the shape. But the fracture is approximately here 45 degree will be found. So this is cup cone failure. So this is all about the video. Please, अगर वीडियो पसंद आया हो तो लाइक करें, कमेंट करें जो भी डाउट है, और सब्सक्राइब करना ना भूलें. थैंक यू.